Okay, so I'm just going to work some of these problems. Some of you got really good explanations of these, feeling good. Some of you maybe are feeling a little shaky, but basically changing forms of a quadratic function. And the first ones are putting vertex and factored form into standard form. Then we go from, factored form to from standard form to factored form. So basically a bunch of factoring. And then we go from standard form to vertex form, which is completing the square. So we'll just begin with the easy ones, basically distributing. Put this in standard form. Basically we can say y minus 16 equals 3 times x minus 5 squared, which is x minus 5 times x minus 5. So then we get y minus 16 equals 3 times, so distributing everything here, x times x is x squared, x times negative 5 is negative 5x, negative 5 times x is negative 5x, and negative 5 times negative 5 is plus 25. Remembering that we're doing the exponent first and then multiplying. So y minus 16 equals 3 times, this would be x squared minus 10x plus 25, right? Because we can combine the negative 5x and the negative 5x. Now we'll distribute the 3 through and get y minus 16 equals 3x squared minus 30x plus 75. Adding 16 to both sides, we get y equals 3x squared minus 30x, and 75 plus 16 is 8591. So that would be standard form. So again, what we're doing is squaring the x minus 5 by distributing, then multiplying by 3, then adding 16, and we're done. So you can do something very similar for B, so I'll skip that one. Coming down to C, we would just do any of the multiplications first. I like to keep the 3 and just multiply these first because I think that's harder. So x minus 3 times x plus 2, we do x times x, that's x squared, x times 2, that's 2x, negative 3 times x, that's minus 3x, negative 3 times 2, that's minus 6. So y equals 3 times x squared minus x, because 2x minus 3x is minus x, minus 6, or y equals 3x squared minus 3x minus 18. So how do you change a quadratic into factored form? Well, you distribute. Okay, so that's the simpler version, or the simpler thing to do is to convert to standard form. Now let's try some factoring to change standard form into intercept form. So to change standard form to intercept form, you factor the quadratic. So some examples here. These ones are a little bit on the simpler side. So this one I'm noticing that the coefficient of x squared is 1, so that's good. Here I'm noticing that all three of these have something in common, so they have a greatest common factor, or something that divides evenly into all of them. So for this one, really what I'm looking for is I'm looking for two factors, and these two numbers should be numbers that multiply to 6 and add to negative 7. So, well, what multiplies to 6? Well, 2 and 3, 6 and 1, negative 6 and negative 1. So negative 6 and negative 1, that's going to add to negative 7. So basically this factors to x minus 6, x minus 1. So if you have a coefficient of 1, you can just look for two numbers that multiply to c and add to b. Sometimes it works, sometimes it doesn't. I can check by converting it back to standard form. So that again would be x squared minus x minus 6x plus 6. So that's x squared minus 7x plus 6. So in fact, I have factored it correctly. So there's really no reason to factor incorrectly because you can always check your answer by doing what we did on the first page by distributing. And so we checked, it definitely works. Here, because there's a greatest common factor, I'm going to factor that out first. And factoring really is division, but you're leaving the factor there so you don't change the expression. So that would be 3 times x squared plus 4x minus 12. Certainly, if I distribute to check, I would get 3x squared plus 12x minus 36, so that definitely works. And now I can see if I can factor this. So again, I'm looking for two things that multiply to negative 12 and add to 4. Well, negative 12, let's see here, that could be negative 6 and 2. That's close, but that adds to negative 4. How about 6 and negative 2? Yep, that should work. So I can say y equals 3 times my two factors, x plus 6 and x minus 2. And just for the sake of being consistent, let me check. So y equals 3 times, so when I multiply these, I get x squared minus 2x plus 6x minus 12. So that's 3 times x squared plus 4x minus 12, which is 3x squared plus 12x minus 36. So it checks out. Okay. These practice examples I'll let you do, but here you're looking for two numbers that multiply to negative 2, add to negative 1. Here you want to multiply to 30, add to 11. This looks like it has a greatest common factor, right? This one, multiply to 16, add to negative 8, multiply to 5, add to 6. This one you want to pull out the negative 2, so your first step would be to say negative 2 times what's left, x squared minus 2x minus 1, and then factor this, which would be what would be left. To complete this example, so what multiplies to negative 1 and adds to negative 2? Nothing. So I think this was supposed to be plus 1, and this was supposed to be minus 2. Now we could do multiplies to 1, negative 1 times negative 1. So y equals negative 2 times x minus 1 times x minus 1, or negative 2 times x minus 1 squared. Otherwise, it just wouldn't factor, which is okay. We're wanting it to factor. So you can complete those other examples. Okay, if your coefficient is not 1, 2, 5, 4, 3, your leading coefficient, and there's no greatest common factor, so 2, negative 5, and negative 3 only have 1 in common, 5, 18, 9 only have 1 in common, then you can maybe factor by grouping. So the process for that is to multiply a by c, and that in this case is negative 6. That's 2 times negative 3. And now follow the same process. Two numbers that multiply to negative 6 add to negative 5. That would be negative 6 and 1. Then we break this apart and say y equals 2x squared minus 6x plus x minus 3, right? Pretty clearly negative 5x is negative 6x plus x. That's where the negative 6 and the 1 came from. Now we're going to factor by grouping. So we're going to factor the greatest common factor out of the first two and out of the second two. So 2x squared minus 6x, that's 2x, and what's left is x minus 3. X minus 3, it's 1, so plus 1 times x minus 3. And now because 2x is multiplied by x minus 3 and 1 is multiplied by x minus 3, we can write y equals 2x plus 1 times x minus 3. And we've factored it into two factors. So again, if we were to distribute this, we would get 2x times that and 1 times that. So we can check to make sure that we get the right thing. First of all, I would get 2x times x, which is 2x squared, 2x times negative 3, which is negative 6x, that's where that came from, 1 times x, which is x, and 1 times negative 3, which is negative 3. So we get 2x squared minus 5x minus 3, which works. Okay, coming over here, again, we're going to do a times c first. The only reason we're doing this is because my coefficient is not 1, otherwise we'd be ready to go. So 5 times 9 is 45. Two numbers that multiply to 45 and add to 18. So that is 15 and 3. 15 times 3 is 45, and when you add them, you get 18. So we'll rewrite this as 5x squared plus 15x plus 3x plus 9. It doesn't matter the order you put these two. It will work either way. So why don't I write it down here the other way? If I did 5x squared plus 3x plus 15x plus 9. So now we're going to factor the greatest common factor out of the first pair and the second pair. we get y equals, these have a 5x in common, so that would be 5x times x plus 3, and these have a 3 in common, so plus 3 times x plus 3. And now we get y equals 5x plus 3 times x plus 3. Okay, so that should work. If we did it the other way, the greatest common factor now is just x. So it would be x times 5x plus 3. And here it would be 3. So plus 3 times 5x plus 3. So now we get x plus 3 times 5x plus 3. So we end up with the same thing, just in reverse order. So it really doesn't matter in that case. To check it, we'd multiply 5x by x is 5x squared. 5x times 3 is 15x. 3x plus 9, or 5x squared plus 18x plus 9. So it works. So to summarize, when you're factoring by grouping, you multiply a by c and get that number. Find two factors that multiply to that number but add to the middle number. So in this case, 15 and 3. Then you break the 18 apart to write it with the 15x and the 3x. Then factor the first two and the second two, a greatest common factor. This should be the same thing if it works. And then we can write it as 5x plus 3 times x plus 3 or whatever it might be. So you can try these two examples here. Okay. This right here, we've now gone from vertex and factored to standard, and we've gone from standard to factored by factoring, and the next one is to go from standard to vertex by completing the square. So I'm going to pause this video and start a new one for completing the square.